we should talk about this too, because I feel like there's something that okay, I was thinking about machine tools the other day, and like a machine tool is 150-pound table spinning around at however many RPMs and then stopping abruptly while the tool engages and cuts. And all of that's happening within like, a thousandth of an inch or a tenth of like whatever it is. Engineering challenges behind getting that to happen. It's really, really interesting because you have to have like acceleration curves and deceleration curves and deflection of the metal as it accelerates, decelerates, experiences forces. All of this nerd stuff is fascinating to me, and I
Yes,
absolutely want to find somebody that can like really jump down that rabbit hole with me
I
and
like it.
and then write about it.
Like it. A little collab.
Yeah, exactly. I don't
Yes, I
know.
like that.
So
I think it's important actually to have that type of conversation too for the betterment of machine shops or of manufacturing as a whole. There's so many engineers out there that design parts that go into rockets and aircraft and
mhm.
satellites and all these other things, cars, semiconductors, whatever. But to understand the kinematics and how these machines actually operate is probably intriguing to them. And if they start digging
Yeah.
into that, they understand the capabilities and what's possible versus not. And that innately helps them with design and all of these other things. So
Well,
there is a lot of value in sharing that type of knowledge.
and I think people underestimate how smart manufacturing is too. Like I think there's kind of this weird bias that like, okay, the engineer designs it and then they punt it over the wall and then it just gets made. And it's like,
Hmm.
okay, but like what's actually behind that is really fascinating because here are all of the things that go together to use that toolpath quote from go from model to metal.
Yep.
Um, there's a lot behind there. And like I've been the engineer that's designed the parts and then just complained when they weren't right. But I never was really engaged in finding out why. It just felt like more work. But I
Right.
think there's a way to present that where it's like, no, this is actually very interesting to you. It'll
Hmm.
help you do better work. It'll help you build better collaborations with your supply chain. And it it's interesting. Like, I don't know. There's a lot to smart manufacturing that goes way beyond um, you know, unused robots sitting in a corner.
Yeah. So speaking of goals and objectives, the goal that I want is an explanation of why we say the easy thing for a machine shop is making the part. All the other stuff is what's so difficult and cost prohibitive.
Okay.
So why is that the easy part? Because it's surely not. I mean, the simplest answer is because of the team behind it, their knowledge, their experience, and their willingness to study and completely understand the nuances of not only the machine, but the CAM program and the metal and the features and all these other things.
So
That's why it seems easy.
my guess as to why machining parts is the easy part is because that's what comes most naturally to the people who run machine shops is like I got into machining because I want to make stuff.
Yeah.
And I
Is it
wonder
because
if
that's the fun part?
kind of, yeah, I wonder like
They put in more energy and brain power to the fun part naturally. I mean, we all
yeah.
do.
Well, so this has been kind of interesting because this has come up in our network calls more than once where we've seen kind of a progression and a development that as business development gets less scary and they get more reps, suddenly that becomes kind of part of the fun part too.
Yeah.
And so I think it's that learning curve. Like anytime you're being forced to learn something while you're being expected to apply that same thing, it's very stressful. And so I wonder if that's part of it too.
Could be.
I don't know. I'm curious to hear people's answers and like,
Yeah, that'll be a fun conversation to have.
yeah, I think so. Huh. Well,
But I
cool.
think you got to start with understanding from a machine design engineer, somebody who designs CNC machines,
Mhm.
all of the inner workings and how they figure all of that stuff out.
I think so too. And then just work it up from the base level. I feel weird saying it base level, but like the foundational principles that you have to overcome with this machine
Mm-hmm.
in order to achieve the outcome you're after. I think what's going to be really interesting from that too is like everybody knows that tolerances are expensive, but why are they expensive? And just show the order of magnitude difference between the complexity of a plus or minus 5 thousandths part and a plus or minus, you know, 5/10ths part.
Right. Well, then
Yeah.
that becomes a GD&T thing too.
Well, that's true. That's true.
So that now you're just getting way too complex.
Probably.
I'd like to know, as a machine tool designer,
Mhm.
what do you start with first? Is it the structure? Is it the spindle? Is it, all, is it the table? Is it how
Yeah.
many like where do you start? Because there's just so many different things that affect each other. And then not only the structure affects, all the inner workings, but then you have the weight of the machine, the floor, the thickness of the floor requirements because of vibration. I mean, there's just so many different things.
That was one thing that kind of blew my mind when I talked with the machinist at my last job. He was like, "Oh yeah, we were working on these gigantic parts, but we had to only do them one at a time because the vibration of the machine next door would, cause
Yeah.
erratic behavior on the one right next to it." I'm like, "Man, I never would have considered that."
Yeah. It's crazy, right?
But absolutely, you're accelerating a 200-pound mass back and forth at however many meters a second. Like that's gonna do some things.
Yep.
I don't know. That's fascinating to me.
Thanks for spending your time with us. There are plenty of podcasts that will tell you what to think. We'd rather help you think through it yourself. We'll catch you in the next episode.